The off-road personal vehicle trend has grown enormously, with skateboards, hoverboards, scooters and electric bikes appearing on streets everywhere. The market for personal electrical vehicles is currently worth about $9 billion globally. Our industry partners are in this market, and they have developed their own range of off-road skateboards, and they want to expand their product range to include off-road scooters. They want to create a more casual experience for those of us who might not be comfortable on a skateboard. And now we've made it easier to have a good time off-road and keep up with an off-road scooter that's smaller and lighter than the existing boards. The three-wheeled scooter offers more stability and control, unlike the conventional two-wheeled counterpart, and the stability really comes in handy when you want to go a bit slower, perhaps you want to stop.
The front suspension has the critical role of allowing the two front wheels to steer by tilting and turning independently. We've done this with a parallelogram geometry and a unique spring location which allows the scooter to tilt with little resistance, but when coming over a bump, it cushions you as you would expect. We've simulated some spring configurations in a physics engine to understand the dynamic modeling of each of these configurations.
As you can see here, I have two suspension systems. One on the left is the conventional spring system on the skateboard, and on the right is the current design for the scooter prototype. On the left, we can see that if this was a scooter and we were to subject it to a load, you can see that it brilliantly dampens the vibrations. And if we were to try and tilt on the scooter, you can see that it really tries to fight you and return to the vertical position. That is not good on a scooter. Otherwise, you would really be fighting to make a simple turn. With this horizontal spring setup, if I was to do the same and put this shock load on the scooter, you can see that it dampens it quite well, but it also has the ability to tilt. And this makes it very, very good for our scooter prototype.
Moving to the rear of the scooter, a dual spring system is used, and this allows for a more compact design. The design had fit into the existing chassis and accommodate for an electric hub motor. There are several tug routes throughout the rear supporting arm. These are to maintain strength whilst being lightweight. Most of the rear suspension is manufactured from 10mm thick aluminium plates, which are laser cut or CNC machined. The sleek packaging of the rear suspension is attributed to the low profile bearings used and the location of the two springs. The ground clearance of the scooter is quite high due to the off-road capabilities, and connecting to the ground are three 10-inch wheels which aid in these off-road capabilities. The handlebar has been designed with an adjustable height for ergonomic purposes. The folding mechanism allows the scooter to be portable. It is critical in the design that it was strong enough to withstand aggressive off-road forces, but also for the folding mechanism to be fast and also secure. Our design means it only takes a few seconds to fold up the scooter. The folding mechanism is machined from aluminium to save weight and also for all components to fit perfectly.
Other ergonomic features include our deck design. The deck's been shaped to accommodate for as many foot positions as possible that we'd expect the user to take when riding. With riding instances such as high-speed cornering and long-duration rides and commutes, our deck features a wide frontal section which sweeps back and narrows down towards the rear end. This benefits the user when cornering, as they can take on a snowboarder stance, and for longer straights, they can take on the traditional scooter stance with both feet pointing forwards for a more familiar feel. Our deck will be constructed out of laminated veneer lumber, or LVL, which is a commonly used manufacturing material and is a strong, lightweight option. Another benefit of using LVL is that it can be laser cut for large-scale manufacturing purposes. Our scooter will cost $2,000 Australian dollars, but have a top speed of 40 kilometers an hour, a range of up to 40 kilometers, and will weigh in at 15 kilograms. These highlighted performance attributes make our scooter perfect for trails, off-roading, and general cruising. With hopes that our prototype will be further developed and eventually brought into the market, We want to give users the experience of riding an electric skateboard who may not currently be comfortable on one. We want to make this industry safer with our product, and we, most importantly, want people to have fun.